So what actually the test bench understand? Let us assume we are here create an environment to test decoder 2:4. If we consider we are going to test our IC 741 op-amp IC. So where we have test? So we test at our lab. So let us assume this is a lab. So in this lab itself we are having a breadboard. So on breadboard we keep our IC. Now what the input we are providing to that IC is, we are having that is the function generator from where we are providing that the input, that signal with different frequencies with that different amplitude, and we are having also power supply. So we are providing the power supply and we will take the output on CRO. It means all the things are available in the lab itself. We are going to test the IC, so we just carry out our design, that is nothing but the IC, that IC741, where we are providing the input from function generator. So we are having a function generator in the lab itself and we will check the output on CRO. So all the facilities are available in an environment. That environment we can call as a test bench. So what here in this particular domain or with respect to your Verilog code, so here we create an environment. That means we create an module such that where we test our design, and what our design is decoder 2:4. So for that we need the input and output itself present in that particular environment. So here we are taking the two inputs for your decoder, and that's why we are taking here that resistor A and resistor B as itself inside in the test bench, and that's why it should be stored somewhere the values. Here we are taking that resistor A and resistor B. In the same way we will check the output, that means we will monitor the outputs. It is not stored, and that's why we will take it wire. Y0, Y1, Y2, Y3 are the wires where we have to carry out our design, and that design can be called as unit under test. So if you are looking for the program, so in the program itself, the test bench program, so we are taking a module test bench decoder 2:4. So what here the Verilog module, how we can call it as test bench? The module without port. Here we are not having any declaration or definition of the ports, so that's why it is of your test bench module. So we are taking the input A and B as an input to test our design, where Y is of your wire, that is of your output. We are just monitoring the output. We are not stored any values. And this is a decoder 2_4, where the first instance you can change here the name also. You can take that UUT1, decoder 1, decoder 2 and so on. So it is your design name, instance name, and what this is, it is known as port mapping. Now there is two types of your port mapping. You can say this is of your explicit port mapping, or we can say the port name or naming, and the second one is of your positional. That means with respect to this decoder design, what the sequence of your input and outputs are coming. The first sequence is A, B and Y. So if we are calling this module in our test bench having the same sequence of your input and output port, then we can call as a positional port mapping. So to avoid the error, mostly we are using that explicit or naming port mapping. So what actually it is, that part we are going to take it. So right now here we understand the resistor A, resistor B, Y of 0, Y of 1, Y of 2. These are the actual ports available in the test bench. We can see these are the actual ports, whereas the A, B, Y of 0, Y of 1, Y of 2 and Y of 3 of decoder 2 to 4, these are the modules ports. That means whatever the design we use here, that is known as modules, and their ports here we used. Now if you are looking for the mapping, so that means resistor A is connected with A, resistor B is connected with B, Y of 0 of your module is connected with your Y of 0 of wire, Y of 1 with Y of 1, Y of 2 with Y of 2, Y of 3 is Y of 3. So it is an environment where we keep our design, and that will be connected with The input and output itself present in an environment through a connections that is known as your mapping. So when we are having a positional mapping, then that case we just write the sequence. But when we are having an explicit mapping or the name mapping, then that times we have to write as dot a dot. When the ports coming to this dot, it understand it is of your modules port. In bracket we have written that a. So dot a understand it is a module port, where in bracket there is a, that means the actual port. Similarly, you can write that dot b with b, comma dot b with b, and in the same way you can write dot y with y, because y of 0 is y of 0, y of 1 with y of 1, y of 2 with y of 2, and y of 3 with y of 3. So here you can check it. Decoder 2 underscore 4 UET dot a dot b dot yy. So it is known as your instantiations. Now after that we just give here the inputs for your a and b. We are wait for some time. We are taking that a equals to 0, b equals to 0. We are wait for 100 nanoseconds. Then ab is 0 1, then ab is 1 0, then ab is 1 1, and we are just wait for 100 nanosecond. What your output becomes. Once it is done, you have to just save this file. Click on your test bench and double click on simulate behavioral model. So let's check the output. So the new window will be generated. Yes. Zoom to full view. Here you find y goes down as our output. So with respect to the inputs 0 0, the first line is 1, 0 1, second line is 1, 1 0, third line is 1, and 1 1, the fourth line is 1. Once it is done, you have to just take a print preview, take a snapshot, and connect with your particular file. So in that way we can complete that experiment number 4 with a test bench. So thank you for watching this video.